So you got to get a pose in front of this. Anything you'd like, right?
That's right. Hybrid. Horns.
Jump. You know, you can do like the silhouette thing.
Oh man, I don't move like that.
You don't move, okay. Here, you got to do this though. This is the next one, right?
Whoa! Okay, yeah, I'll leave that. I'm not gonna try that. I'm gonna pull everything. Hybrid manufacturing, not just the company, but like the actual technology itself, was really big in 2018. If you went to IMTS 2018 and walked the floor, you walked the Emerging Technology Center, there goes the luggage, people would not shut up about hybrid manufacturing. Everybody was doing it. But you know who did it first? Jason Jones, hybrid manufacturing. And that's who we're visiting today. And I'm really excited about it because he's a really nice guy, he's a cool dude, he's a genius, and most importantly, my favorite thing that Jason Jones and Hybrid Manufacturing has done, industrial infographic, the 7 families of additive manufacturing. And if I find out you don't have it, I will make you download it. What's going on, Jason?
Hey, the man of the hour, Steve, Stefan, all of the above. Great to see you.
Thank you, sir. I can't wait to see what you guys have in store for us. And yeah, let's go check it out.
Perfect, let's go. By request,
yes.
We have the 7 families, Texas-sized.
This is my favorite thing I've seen so far. I love this so much. I was just saying in the car that I have this document, this PDF, on every single work computer I've ever used. Well, I only have one right now, but every single AMT work computer they've given me has a copy of this saved to the desktop. I have it on my phone, and if I meet anybody and we're talking about this stuff, I make sure they download it too. So great to see this in person.
That's great.
Very
well,
nice.
We actually made it for our employees initially because we're focused kind of on this end of the spectrum, but there's so much of additive that's so useful. Right. That we want our employees to be aware and able to be conversant, at least, across the 7 families.
I also like to reference this. Lately, I've been referencing this document, this infographic a lot, because it is a standard. It's a standardized infographic. And every now and then, because I follow a lot of manufacturing news, every now and then I'll see a headline that says, oh, this new form of additive is taking over, blah, blah, blah. And it's like, okay. Let's consult the document, the text, and yeah, it's nothing new.
Okay, so welcome to our hybrid machine.
Thank you.
Absolute pleasure to have you here. If you look carefully in the tool magazine, you can see we've got normal milling and probing, etc. Right. And then we have a nice red head. Yeah. And that's a 3D printing head.
Wow. See, I see a probe, I see drill bits. I think they are drill bits, right? I want to make sure I'm not confusing the end mill.
They're technically end mills.
Oh, they are end mills?
Yep.
Just ball nose?
Correct. We got ball nose and normal.
I see a face mill and then something interesting.
That print head is tool number 8.
Okay.
So if you'll do T8, yep, T8, and then we should get ATC forward. Behold.
Then just like that, our CNC mill is now a 3D printer.
That's exactly right.
That's so cool. Now, what else?
The first time you've ever done this is a special moment.
It is a special moment.
It deserves another pose in front of the... No, I'm just...
All right, I'll try something later, I promise.
That's good idea.
What else needs to be set up? So I see you've got, you know, your compressed air jet and maybe coolant is in this machine, but obviously something needs to feed the 3D print head.
Correct. So it needs feedstock. Mm-hmm. In this case, we're going to use injection mold grade pellets.
Okay.
And it also needs electrical, right? Signaling and temperature and other things. So I'll show you what the feedstock looks like, actually.
Okay.
So same as you'd use for injection molding, right? Rather than using filament, this is just pellets.
Very cool.
And that allows us to drastically reduce the cost. Especially as you go larger scale, having low-cost feedstock really adds up over time.
Okay.
We have a variety of setups. If you notice here on this image, we've got fully automated solutions, and also we've got manual solutions. And so it just really depends on how often you're going to use it. Is it truly a production environment? And so Tyler will set this one up for us.
So when you say manual, you mean like one of these tool heads, one of these 3D printing tool heads can be put in something like a Bridgeport?
Absolutely.
Wow, that's sick. Oh wow, so the spindle's actually turning now.
Yep. When we looked at modularizing this, we said most extruders are long, large, heavy devices.
Yeah.
How can we get to something modular? The only way we could do it for this scale of machine is to use the spindle.
Right.
Which makes perfect sense. You have a really sophisticated high power motor, why duplicate it?
Oh, now we're seeing the gloves required.
Here, hand it. Here, put a glove on. It's hot, but hand it off to him. Just pull it out and hand it to him, let him play with it. You have to sculpt the best flour you can at the top because it's still warm.
Here's our little bundle of purged carbon fiber ABS.
This is carbon ABS. Wow.
So seconds ago it was pellets, and now it's whatever you tell it to be. So why don't you use the air gun? Let's clear a little space here.
Okay.
So that you can, so we have something to deposit onto. Is that good?
Perfect. Sounds good to me. We don't get too much backblast. Is that enough room?
It's great.
Okay.
Oh, sorry.
That's cool enough. You can touch it now and you can do whatever you want. Often we drop it in the bottom of the machine if you're done.
Yeah, it's just a little bit toasty now. It cooled pretty quickly.
Yeah. And if you're really talented, you can sculpt, right? So then you have a desk sculpture.
Look at that.
So at the end, remind us. We'll give you a piece, and then you can then sculpt to whatever you want.
Cool. Yeah, this one's definitely cool.
Nothing is more romantic than saying, I hand sculpted this carbon fiber flower for you. I'm just going to point out one thing. When you 3D print, you have to 3D print onto a substrate.
Yes.
Often it could be a bed, a heated bed. You can use whatever you want. In a machine tool, we find it's really easy to use a vacuum table just to hold down a sheet of plastic.
Gotcha.
And so that's what you see in there as the base.
Oh, great.
Because we can
that's the vacuum line for the table.
That's the vacuum line. And we can cut a sheet as big or as small as we want.
Awesome.
And so it's just really fast and easy. So programming continues to improve even for milling, right? And the more we can put into more intelligence we get into CAM, the easier it becomes for everybody. And so to say to you, CAM is now mature for hybrid would be an overstatement.
Wow.
Right? But for a lot of the application space on particularly tooling and other types of parts, it's not very hard.
Gotcha.
You've already got a knowledge of 3D CAD/CAM, which is the hardest foundational knowledge.
Right.
Right? It really is just a few extra M codes.
Yeah.
And so until you get to part assessment, and then you have all the things additive has. You're not just making a shape. You're making whatever the internal, either microstructure if it's metal or whatever's happening with your polymer chains in its conditions.
Yeah. I was expecting it to look like the strand of extruded material, but I like how it's nice and close to the bed.
Just a little for fun, the pressure inside that head gets to about 3,000 PSI.
Wow.
And so, talk about working under pressure. That's what polymer does, right? It's best worked under pressure and some heat. In terms of output, this is about as slow as we run this head ever.
Oh, really?
It runs about 2,000 times what a typical desktop 3D printer outputs for the same amount of time. It's going to look like this every layer for about no, it's longer than that, like about 12 more minutes.
Okay. just did both in like a half hour's time. Movie magic will make it seem much shorter, but we just printed and cut the same part, same machine. Fascinating.
Glad you were here for it.
Yeah, thank you for having me. This was a real pleasure.
Enjoyed it as well. Thanks.
Well, how about that? We got to see the entire hybrid manufacturing process, from laying down material to actually switching to a cutting tool, cleaning up the part, and you know, getting clean off the chips. And we even got to make an additive flour, which I do need to go back and get, but for the sake of continuity, we're leaving. Until next time, Tejas.